In this lesson, we will study the light emitting diode, or LED for short, and put it into practice. An LED is a semiconductor device that converts electrical current into actual light. In the circuit diagram, the LED is indicated as follows. To connect to the network, the LED has two outputs, anode and cathode. They determine the direction of the DC current, so if they are connected incorrectly, the DC current will not pass and the LED will not light up. To determine where the cathode is and where the anode is, you just need to compare the length of the legs. The long leg of the LED is the anode. We connect it to plus. And the short leg is the cathode. We connect it to minus. Now let's move on to practice. We are trying to control the LEDs using Arduino. To do this, you need to study modules number 15, number 16, and number 17. Let's start with module number 15. Let's start connecting. As we can see, module number 15 already has the 10th pin and G and D in. We just have to connect them correctly. We close pin 10 through the resistor so that the LED does not burn out, and connect G and D directly to the minus of the LED. Now let's connect the Arduino to the power supply module. We will do that through module number 8, Arduino Power. VIN is connected to Vault Plus, and G and D to G and D. Also, turn on the power supply module itself. The connection is ready. Now, let's open the Arduino program and write the commands. Declare pin 10 as output. Turn on the LED. Wait 1 second. Turn off the LED. Wait 1 second. Now, we can run the program. So, what do we see? The LED turns on and off each second. Let's learn how to control the brightness of the LED. Before you start practicing though, you need to understand how Arduino changes the brightness of the LED. This method is called pulse width modulation, or PWM for short. PWM is a way to control the power at the load by changing the duty cycle of the pulses, or the width of the pulses, at constant frequency and signal amplitude. Arduino has 6 hardware PWM modulators on analog ports. These are pins 3, 5, 6, 9, 10, and 11. On the board, they are marked with a tilde sign. The PWM signal is controlled using the analog write function, which generates an analog signal at the output and sets the duty cycle of the pulse. Now let's open the Arduino program and write the commands. Change digital write to analog write, and change high and low to random values from 0 to 255. Also, add another line analog write. And we can run the program. What do we see? The LED changes brightness every second. Let's now learn how to control multiple LEDs. For that, we will use module number 16. The connections are as follows. L1 is connected to pin 9. L2 is connected to pin 10. L3 to pin 11. And G and D to G and D. The connection is ready, so now open the Arduino program and write the commands. Connect red LED to pin 9, connect green LED to pin 10, and connect blue LED to pin 11. Declare the pins to which the LEDs are connected as output. Supply voltage to pin 9, wait half a second. Supply voltage to pin 10, wait half a second. Supply voltage to pin 11. And add 3 more analog write lines. Now we can run the program. Voila! We can see how several LEDs automatically turn on and off every half a second. Let's now learn how to control RGB LEDs. In our case, this is the 17th module. RGB LED consists of 3 LEDs of different colors in one package. You might know that red, green, and blue can combine to make any color. But what about connections? You should arrange pins 9, 10, 11 and the common contact pin like this. On this module, this connection can be either a plus or a minus, depending on the version of the IoTBoard. If the LED does not light up, try connecting the pin to minus. The connection is ready. Now open the Arduino program and write the same commands that we used earlier to control several LEDs. Here you go. You can see that the LED automatically changes its color according to the given period of time. Congratulations! We have gone through all the basic principles of the LED and we have put it into practice. Well done!